Let's talk a little bit about air conditioning troubleshooting. I want to talk about the condenser fan issues first. And the reason I want to do this is because I recently asked the students a question. I gave them an example of a troubleshooting where the compressor was running high amperage, condenser fan was running high amperage, and I gave them some pressure scenarios where the high pressure side of a system was running extremely high. In order to really do this, I'm going to use the Simutech simulator for the air conditioning. Now, I have set this equipment to be a split system and using R410A. So the first thing let's do is let's go ahead and look at a normally running system. So I'm going to select my system here. Okay, I'm going to power it on. My thermostat is set for 75. The indoor room temperature is 85. My outdoor ambient temp is 95, and I have about a 50% relative humidity. Now I'm going to run this real time. I'm not going to change to run faster because I want you guys to see exactly what's going on. So let's throw some gauges on the system. Of course, it's easy here just to push a button and throw some gauges on. What we are seeing, we have a blue gauge connected to the low side of the system. Doesn't matter where it's at on the low side of the system, it's all going to have the same readings. We have our red gauge connected to the high side of the system. Okay. And again, it really doesn't matter where it's at on the high side of the system, it's there. So you will notice that the numbers over here on the gauges, the low side is dropping temperature because I have this set for temperature. If we look at pressure, you'll see my high side is around 411, low side is 142. And the low side, which is evaporator, is consistently dropping as time goes on. High side is coming up a little bit. Let's go back to our temperature conversion, and you'll see my high side is running around 129 or 121, 122. My low side is at 48. Okay, my indoor temperature continues to drop. Let's throw some temperature probes in here. Okay, I'm going to put one on the inlet of the condenser, and I'm going to just double click on this, and I want to choose the supply air just so we can see what's happening with the air temperatures. So let's look at the low side first. My evaporator coil is about 45 degrees. My supply air is running about 67 degrees. Okay, if I click on this and move that to the return air, my return air is at 83 degrees. So if my supply air, let's make this easy. So between 65 and 83, I have about let's say an 18-degree temperature split, which isn't bad. Okay, I'd like to be 15 to 20. I'm fine there. Now, let's move one of my temperature probes back to my condenser inlet air, otherwise known as ambient air, because this is really important. So the yellow probe is now on my ambient air, which is outside. We have 95 degrees. Okay. So I have a 95-degree outside temperature. My condensing temperature is 122. So if I do my math right, we take 122 and subtract 95. Let's pull out my trusty iPhone here in the background, and let's look at the temperature. So we have 122 minus 95. Okay, that's about 27 degrees. I'm okay with that. My condensing temperature should be roughly close to 30 to 35 degrees over ambient temperature. So again, condensing temperature, 30 to 35 degrees over ambient temperature. The more efficient the unit, the lower that's going to be. So this is an R410A unit, probably about a 13 SEER. I'm okay with 27 degrees. Okay, that's a normally working system. Now let's go look at the electrical side of this. Okay, electrical side, again. Let's take an amperage reading. I want to take an amperage reading of my compressor. I have 18 amps. I want to take I'm going to move that. I want to do the outdoor fan motor. I have 2 amps. Okay. Let's look at the specifications. What should I have? Okay, amperage of the compressor is about 17 amps. Condenser fan should be 2 amps. Right where I want it to be. Okay. By the way, this diagram is actually incorrect for a split system on Simutech. It's been reported to the author of Simutech, but unfortunately he passed away before he could fix it. A residential split system should have 2 power supplies, and the only thing connecting the outside unit containing the condenser fan motor and the compressor is the low voltage wiring coming out of the thermostat. So just keep that in mind. Okay, so that is a properly running system. Amperages are okay. We have our pressures that are running okay. So let's go ahead and let's exit out of here. I'm going to go back out. Now I'm going to run it in a fault condition. Okay, I've actually put a fault condition into here. Okay, so let's go ahead and run with the fault. Okay, no cooling, but air is blowing from the register. So we are going to turn the system on to see exactly what happens. Okay. I'm going to put my gauges on. Actually, let's exit back out of here because for some reason it gave me the wrong fault. So let me manually select what's going on here. Okay, system not cooling adequately. Let's go ahead and turn my power back on. Okay. Let's throw some gauges on here. And I want to throw my temperature probes on. I'm going to put one on condenser fan inlet, and I'm going to put the other one on my just on my supply air. Okay. Now, what's the first thing that you notice going on here? Okay, we have our pressures that are rising. Both sides, my high side pressure is rising, my evaporator pressure is dropping. Let's go back to temperature here. Okay, evaporator's 53, my outside air temperature is continuing to rise. Remember, we want it to be about 120 or 27 to 35 above ambient temperature is what we want our condensing temperature to be. So if we look over here, we have a condensing temperature, or we have an outside air temperature of 95 degrees. So if I go the 30-degree rule, we're already over it. Okay, I'm hitting 40 degrees. Now let's go to the, let's go over here to the electrical, throw an amp clamp on my compressor. I'm already at 19 amps. Okay, if we look at the specification, we want 17 amps. My condenser fan, I should have 2 amps on. Let's go ahead and go back over here, see what my pressures are doing. I'm continuing to go up. Let's go back to my electrical. Let's put it on the outdoor fan motor. In this case, I have 0 ohms on the outdoor fan motor. Which anytime you have 0 ohms, you have something not working. Okay, but what I want you to, again, see is what's happening. If my outdoor fan is not pulling enough air or no air, my high side pressures are going to continue to rise because we're not rejecting heat, okay? My discharge line is going to be extremely hot. So let me just put compressor discharge. My discharge line here is going to start getting extremely hot. And sooner or later, it's just going to, we're going to cut out the compressor because of a high pressure switch opening. And I think that's what just happened here. You see my pressures are dropping. Okay, if we go back to the electrical side, okay, we will see, let's put the amperage back on the compressor motor. Oh, we're still drawing 19 amps there. Okay, so we're still drawing a lot of amperage on this compressor. Notice what's happening on my pressures here as well. Sooner or later, the high pressure switch will open. We'll allow that pressure to drop a little bit, and this will come back on. Now, in this case, we have a fan not working whatsoever. So let's go to the electrical. I'm going to shut the power off, okay, because I can't ohm out a motor without the power, with the power on. I'm going to select my ohm meter, and I'm going to ohm out the condenser fan motor, run winding. Again, common to run. Okay, these motors are in here backwards because it's L1, L2, really doesn't matter. So I have OL on the run winding. And let's go to, oh, it only gives me one choice here. Okay, let's make sure the capacitor is good. You'll see that it goes up and then to open. So my capacitor is actually good. Okay, so we have a bad outdoor fan motor. So if I do the repair work, okay, out compressor, where is it? Outdoor fan won't start. So let's go ahead and select that. Okay, outdoor fan motor winding open because we already did that. Let's replace that motor. And let's just repair that in the magics of Simutech. Okay, now let's go ahead and power on this system again. I'm going to move that amp clamp down to the outdoor fan. We know that the outdoor fan is now doing something because it has 2 amps, which matches the specification. Let's go back to our main screen and watch what is now happening on these pressures. Okay, we now have a 65-degree coil. It's dropping. That's my evaporator coil. Okay, I'm fine with that. Okay. We have a 95-degree inlet. My ambient temperature is 95. My condensing temperature is 124. That's like 29 degrees. I'm really good with that. Okay, and as that coil continues to get cooler, we'll see that temperature drop over there. Let's check my temperature split. So let's do a return and supply. My temperature split across the coil with airflow. Okay, returns 84, supplies 67. Okay, it's about a 17 degree. I'm perfectly fine with that. So that condenser fan, if it's not running because of an open winding or not moving enough air, we are going to seriously affect the high side pressures of a system. I hope that explains a little bit about what happens with a refrigerator, with an air conditioning system when that outdoor fan is not running. We just don't discharge heat. We have to move air across that coil to get the heat collected from the inside out of the outside. And we made our corrections. So